Okay, potential and kinetic energy. Before we get that, we're just going to go back to just basic energy. The definition for energy is the ability of an object to exert a force. So how much energy you have is how much force you can make. Think about yourself as a person. Your muscles make you have more force. It's my very fancy picture of muscles. We talked about a little bit yesterday, what is the unit for energy? Do you remember? The other one we talked about? Yep, energy is measured in joules. Capital J is what you'll see in your problem. Anytime an object exerts a force, energy is transferred. So we're not creating or destroying energy, we're transferring it from one thing to another. And then there are different forms of energy. Same way we had different forces. Okay, the two forms of energy we've got that we're going to talk about are potential and kinetic. Potential energy, we're going to think about it like stored energy. It's stored up. We're not using it at the moment, but we can use it in the future. Objects have potential energy based on their height. So if something is up high, it's going to have more potential energy than something that's down low. The higher up, that's not how you spell higher. The higher up that the object is, the more potential energy it has. And here's your formula. PE stands for potential energy. M will be mass. G is gravity. What is gravity always worth? 9.8 meters per second. And then H is your height, measured in meters. So that's how you find potential energy. Kinetic energy. Kinetic means motion. So energy of motion. You have to be moving to have kinetic energy. So motion is this next one as well. If you are not moving, then you don't have kinetic energy. The faster you're moving, the more kinetic energy you have. So this formula is a little bit different. Kinetic energy is 1/2 mass times velocity squared. So you gotta pay attention to that one. I'm gonna put a second power on there, do some multiplication, and then cut that number in half. Any questions about any of this vocab? Okay. Not yet. On the next page of this, we've got some examples to work through. So this first set are for potential energy. The formula is mass times gravity times height. Gravity always equals 9.8. Okay, this first one says we have a wrecking ball with a mass of 2,300 kilograms and a crane that is 37 meters tall. So what does 2,300 stand for? the M, and 37 is height. All right, so potential energy, M or mass number was 2,300, times G is 9.8 every time, times 37 for our height. Plug that into your calculator. $833,980. And then your unit for energy is always what number? Or what letter? I don't remember. Energy is always joules. Energy. Okay? Anybody get something that wasn't 833,000? Okay, the next one, Andrew Luck throws a .43 kilogram football. How much potential energy did the ball have at its highest point, 37 meters off the ground? So what does that .43 stand for? Mass. 37 is the height. And when you plug that in, what's it going to look like? Search yourself out. 55.9. No, hold on. What's the problem look like? Okay, 0.43 times gravity is always in there, 9.8. Again, we're doing 37 meters. It was 9.8.
Yeah.
So since it's okay, yeah, we can just do 55.9 is always what unit? Joules. Okay, the next examples are about, they say find the kinetic energy. So remember the kinetic energy formula. You do 1/2 times the mass times velocity squared. So for the first one, we have a mass of 1,300 kilograms. That goes in the M spot. And velocity is 89 meters per second. So they told us that's our V. So when you fill this in, the 1/2 is always there. It's part of your formula. Then what are we going to do? Times, our mass was 1,360. And then what do you do with the velocity? Multiply. But it also has to get squared, so it needs the second power. If you plug this in my classroom calculators, you can put it all at one time, that's fine, but you need to make sure 1/2 gets put in parentheses. So the parentheses buttons are right above the numbers. Do parenthesis 1 divided by 2. and then close the parenthesis. Then you can hit times 1,360 times 89, and there should be x squared on the side. What's it by? Right above the LOG button. And then if you hit enter, that should do all of that in one go for you. Yeah. Plug it in. What'd you get? $280. Yep. Okay, and then kinetic energy also in joules. Okay.
So any type of energy is.
Yep. The unit for energy, all of them. All right. This last one says kinetic energy does 68 kilogram sprinter. How much kinetic energy does a 68 kilogram sprinter have if he reaches his top speed of 9.2 meters per second? Excuse me. So what does 68 stand for?
Mass.
68 is our mass. 9.2 velocity. Okay, so that's all we need. When you plug this in, kinetic energy equals, what's this look like? 1/2. 68. 9.2 has to be squared. Same thing, you can type that all in, just make sure 1/2 is in parentheses, and that you put 9.2 with the second power. What'd you get? 0.76 joules. Okay, any questions about either one of those formulas? Okay, let's look at the next page. So we're just going to go over the front of this quickly because it's about the same thing we just talked about. So potential energy, like what matters for potential energy? Yeah, height, where the thing is at. Its position is what gives something potential energy. Anything with potential energy has the potential to do work, like we talked about yesterday. But this is only released if the object falls. And then your energy is transformed into work. Because energy or potential energy is related to height and mass, if you have more mass, then you're going to have more potential energy. And then if you're higher, you'll also have more potential energy. You can think about this like a bowling ball versus a kickball. If you're holding them up the same height, which one has more potential energy? The bowling ball, it's going to go faster. It has more mass. It's heavier. So that means it has more potential energy. A kickball is lighter. it will have less potential energy. They did an example over here. How much potential energy does a 4 kilogram object have if it's 5 meters off the ground? So this is just like the ones we did. They plugged in 4. They used 10. I want you to use 9.8. I don't know why they always round it up. And then they multiplied that with the 5 for the meters and got 200 joules. Okay. And then same thing for kinetic energy. Kinetic energy depends on what makes kinetic energy happen. What has to be happening for you to have kinetic energy? You have to be moving, in motion. So that's what the velocity is. If you're heavier, you're going to have more kinetic energy, just like the bowling ball and the kickball. The bowling ball will have more kinetic energy. And then if you're moving faster, so like if you think about baseball, somebody who throws a fast pitch, that fast ball is going to have more kinetic energy than just like tossing the ball. Your kinetic energy helps you overcome the force of gravity, and that's how you move. Any questions about these? Okay, let's do a few more review problems on the back, and then we'll do a couple potential and kinetic energy questions. For this top box, talking about what the thing is and what its unit is again. Force or force weight. What is the unit for force? Newtons. V stands for what? V. Velocity. What's the unit for velocity? Meters per second. Okay. P was the one we talked about yesterday. We haven't used it. Momentum. That one is the kilogram meters per second. I haven't used that one. What does H stand for? What does H stand for? What unit do you use for height? Yeah, meters, some distance. Work or energy, we use the same unit for both of those. Joules. And that leaves P. Capital P stands for power. We measure power in watts. Think about a light bulb being powered. Let's do this box over here in red. What is kinetic energy? I mean, that's the unit, but what does kinetic energy mean? Motion. Potential energy is what? Position, E. What is work? I did that yesterday. No. A. Work is using energy. It also can create energy. Joules is your unit. And then H. Height is how far above ground you are. So B for that one. Okay, any questions there? All right, let's go to the box that says potential or kinetic energy. We're just going to pick which one. So if a car is traveling 45 miles per hour, is that potential or kinetic? I didn't hear you say that. Yes. Oh, sorry. Literally didn't hear. So, traveling, kinetic. If a rock is on a ledge 5 meters high, potential, it's not moving, but it's above ground. A car is resting at the top of a hill. What'd you say? Yep. A ball is thrown into the air and is still moving. It's kinetic. And then a ball is rolling on the ground. Also kinetic. All right. Let's go over here to circle the one with more potential energy. So remember, potential energy depends on height. So which one has more potential energy? A 25 kilogram mass or a 30 kilogram mass at the top of a hill? Yeah. More mass, more potential energy. Which one has more, a car at the top of the hill or the car at the bottom of the hill? Car at the top. What about a plane on the ground or a plane in the air? Air. And a full plane or an empty plane if they are both flying? Yeah, why full? If it's full of people, it's heavier than an empty one. All right, and then same thing, but with kinetic energy. Kinetic energy depends on mass and velocity. So which one is going to have more kinetic energy? 25 kilogram mass or a 30 kilogram mass if they're both going 5 meters per second? 30. If you've got two 10 kilogram masses, but one is going 75 and one is going 45. The one going faster, 75. A car at rest or the car rolling down the hill. Movement matters. And then a heavy bike or a light bike. Heavier bike has more kinetic energy. Okay. Questions about that part? We're going to move down to this one that says a rolling ball has 18 joules of kinetic energy. So right here. So what is the formula for kinetic energy? What do you need? What does that say there? 1/2 m for mass, v for velocity squared. So we have a ball that has 18 joules of kinetic energy, and is rolling at 3 meters per second. So what parts of the formula do we already have? Okay, 18 is kinetic energy, it goes first. 1/2 is always just there. M stands for mass. Do we have that? Nope. So we need an M in there. And our velocity, three gets squared. Okay, so we need to work this out so that we can get M alone, but we've got to do the work that's happening in here. So what piece of this should you do first? 3 squared. Think about order of operations. We need to do exponents. So what is 3 squared? Yeah, that means 3 times 3. Okay? What next? What math is the 9 doing? Multiplication. So we've got 1/2 multiplying and 9 multiplying. Yeah, what is 9 1/2? What is, I said in half, but let me rephrase. What is half of 9? Did you already say? Okay, so we have 4.5 multiplying with M. What do we need to do to get M alone? Divide both sides by 4.5. So you need to figure out what is 18 divided by 4.5. Just 4, okay? And this is for, what did we just find? What does M stand for? Mass. So 4, what unit does the 4 need? Mass is measured in what? Yes. Kilograms. So please make sure you're putting your units on your answers, especially on your quizzes. Okay. Let's do the one below that next. A 4 kilogram bird has 8 joules of kinetic energy. How fast is it flying? What are they asking us to find? What's the V? We're looking for velocity. They gave us 8 joules for kinetic energy. And 4 kilograms for which letter? Kilograms is for our mass. Okay, so when we plug this in, kinetic energy goes first. So what's our problem starting with? 8. So kinetic energy equals 1/2 times, what's our mass? 4. Times 4 times velocity squared, which we're looking for velocity. So we're going to leave V there. What are we going to start with first this time? Can I use my exponent? Not yet. So if I can't start with my exponent, what's my next step? Yeah, 1/2 times 4. So what is 1/2 of 4? 8 equals 2v squared. Good. Divide the 2 on both sides. 4 equals v squared. Okay. To undo a power, you have to take the square root. You're looking for what number times itself makes 4. Code already said the root of that is 2. There's also a button on your calculator. What unit do I need to put for velocity? Meters per second. Okay? Let's do one more of these over here on the very bottom. This one says, how high up is a 3 kilogram object that has 30 joules of energy? Which type of energy talks about height? Potential. So we need the potential energy formula. Mass times gravity times height. Will you be here in the morning? See you then. What part are we starting with when we plug the numbers in? Yeah, potential energy is the 300. Do we know our mass? Yep. M is 3. What are you going to put for G? 9.8. And then do we know our height? Nope, leave it the letter H. Okay, and then what do you need to do first for this one? We've got multiplication there. 3 times 9.8. What? 14. And then to get H alone, divide that. What unit do we need for height? Meters. Okay. Questions about potential or kinetic energy? You're going to type exactly what it says here, tinyurl.com/ICP coaster. I'm also going to pull it up on the screen. So this asks you to find, they did the first one for you. Click play to watch this roller coaster once. How'd you get smaller? Okay, so this is showing you, this pie chart is showing you pink is potential, blue is kinetic energy, and then it's also showing you its velocity. So after you've watched it, if you push this step button, it gives you each step. It'll go through it again, but you can also just click on the step one at a time. So they did step one for you. They asked how fast is the roller coaster traveling. Your velocity tells you that information. Then it says how much kinetic energy does it have. So at this spot, step one, this pie chart is all pink, which means it's all potential. None of it is kinetic. So 0%. How high is the roller coaster off the ground? Estimate between 1 and 10. So we'll say like right here's 10, it's almost there. They picked 9. And then how much potential energy does this coaster have? If the whole pie is filled up. For step 2, here's the pie chart, here's the velocity. You need to decide down here what number you want that to be out of 10. If this is 9, that should help you pick. Your kinetic and potential energy questions need to be answered in a percentage, and you're just going to estimate because they don't give you any numbers in the pie chart. But if this is really close to being all the same, whoops. Yeah. So you're going to do that for each step, and then there are questions on the back to answer. Yep, they did step 1 for you. Here's step 2. Oh my gosh. If you're watching the video and you need time, press pause. Okay, we're skipping step 3 because it's not good. This does say 20. Yep. So we're skipping step 3. Here's what step 4 looks like. Again, if you're watching the video, pause so you can fill out your information. All right, step 5. Our pie chart is all blue. You're at 16 meters per second for your velocity. Pick your height. If you're watching the video, pause. Okay, last one for step 6. A big chunk is blue. A little smaller chunk is pink. 2 meters per second. And you're this high off the ground. Pick your number between 1 and 10 for that one. If you're watching the video, pause while you get those recorded. Okay, and then once you have all of that, you're going to answer the questions on the back page. Put your information into these tables. They made 1 for kinetic energy, 1 for potential energy. It's like for step 1, it was going 3 meters per second, and the kinetic energy was 0%. Potential energy, it was 9 meters high and 100% potential energy. So for each step, you're going to put numbers in kinetic and then numbers in potential. Once you've gotten those tables made, you'll use the tables to graph velocity versus kinetic energy and height versus potential energy. So like for this 3-0, velocity is on the bottom. That's like your X value. Your energy is on the Y-axis. So 3-0, they did number these by 2s, so be careful. Go over to 3 and put a dot in the middle. Same idea for potential. Height is your X value. Energy is your Y value. 9 and 100. So over and then up before you put your point on the graph. And then once you're done with that, they ask you a couple questions about your graphs. And that's all you need to do for this one.